In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths Mechanics paper 4.1. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 7, they talk about a particle X moving along a straight track. Let's try and draw this a little bit. You don't have to, but I find it helps. It's from a starting point of 0 or O, an origin. And at time 0, its displacement from X is given to you by this equation here. They actually forget what they want to, at the moment. Let's just think about what happens here. There's a particle here. And what happens it? You don't have to do this to know to answer the question, but honestly, if you want to get 100%, you probably do want to understand what I'm about to say. You want to understand what's happening in the question as much as you can. So for example, at time 0, put 0 in here. Displacement is 0, as you'd expect. He's sitting right there. But what happens after 1 second, say? You put 1 in, you'd get 3 minus 6 minus 3. So after 1 second, he's moved over here. He's moved to the left. After 2 seconds, what happens? You can put in some numbers here. After 4 seconds, I think you'd find they're back at 0. And at, say, 1,000,000 seconds, they're all the way over here. So what is actually happening here is going this way, stopping, coming back, and going that way. Other things might be happening. It's not that complicated of a function, but it's not a quadratic that we're used to or a cubic. So maybe he goes like this and it waves around the place. It's not the case. What's happening, like this function actually looks something like, let's say something like that. It nearly looks like a quadratic. It's just going off a little slower than a quadratic actually. But it looks something like this. At time 0, he's going down to the left. They're going off to the left. And at some point he stops and then comes off to the right. But you maybe don't have to fully understand what it looks like, but you do want to have some idea that this guy is going off to the left, coming to the right. It certainly helps in this question specifically. Okay, so in part A, they ask you to find the time at which X is instantaneously at rest. That's a good clue because it's quite hard to answer the rest of the question without that. And then it wants you to find the total distance X travels between 0 and 16. Let me first do this question wrong. You could have put 16 in here. And what number is that actually? 96. If you put 16 in here, S of 16, you'll get 96. So after 16 seconds, they're down here somewhere. They're down at this point. Students might have just put in 96 as the answer. Started here, ended here, moved 96. Without understanding that they went this way first, then down here. What we really want to know is how far did they go down here, turn around, and go back. The total distance traveled is this distance plus this distance again plus this distance, which is 96. Okay, to get that, we do what they tell us here. The time it was instantaneously at rest. Also at this point, I'll just rub this out. Actually, the very first thing I would have done in this question, when I seen this, I would have just wrote down V is equal the derivative. Because, well, I do this all the time in physics. If I'm given velocity or acceleration or displacement, I write down all three. So differentiate this, we'd get 3 over 2 times this is 9 over 2. And 1 away from this is 1 over, is a half minus 6. This question, like, we never need A. We don't need it, but still, I would write it down. The first thing I wrote when doing this question is all of these. I would write 9 over 4 t to the power minus a half. I would just always have my S, V, and T. Even if it was a simple question that you could have used equations of motion, always use differentiation and integration. This will be helpful in the second part. Okay, so when's it instantaneously at rest? It comes up a lot, that word. At rest, it means the velocity is 0. That's what they want. They wanted you to find this line here.
and they want you to put it equal to 0. 9 over 2 t to the power of a half minus 6 is equal to 0. They want you to solve that. That's it. There's only one unknown. Rearrange some things here. T to the half is equal to 6. The 6 comes over. Multiply it by 2. This 2 comes over. Divided by 9. This 9 comes over. T to the power of a half is equal, 12 over 9, which is 4 over 3. And then square both sides. T is equal 16 over 9. We just found out when it turns around. That's what this tells us. This tells us when it turns around. So the next thing you want to do is find out how far away it is. What's the distance here? So this distance is 96. What's this distance? It's S at 16 over 9. After this many seconds, what's that? Like nearly 2 seconds. What does that equal? It equals 3 times, not t. T is this time here. 3 times 16 over 9 to the power of 3 over 2 minus 6 times 16 over 9. Put all that into a calculator. Let me just see what number I got. I got minus 32 over 9. It's minus because it's on the left. It's the left of the 0. So really this distance here is 32 over 9. So your total answer, again, don't add this with this. It's 2 of these. It's 1 and another one of them. So it's 2 times this plus 96. The final answer is 32 over 9 plus another 32 over 9 plus 96. That's the total distance traveled, which is 928. 928 over 9. Is that right? Oh yes, this would be times 9, which would end in a 4. 4 plus another 4 would be 8. Okay, I just couldn't read my writing if it was 28 or 29. That's your final answer. What's that in meters? That's total distance traveled. Okay, that's it for part A. 6 marks for that. That's because they didn't really hold your hand too much. They didn't tell you they didn't give you a hint to differentiate to get velocity. They didn't hold your hand that you'd have to have 2 of these. The only thing they did slightly was they told you instantaneously at rest. They gave you that clue. Instantaneously at rest should have made you think velocity was 0. Velocity 0 should have made you think, well, the derivative of distance is 0, and so on. Okay, let me clear this off and we'll do part B.
If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below.
Actually, I shouldn't have rubbed out everything. I did need these equations again because the second part of the question is it's combined. And let me draw the picture even again. The first part we had at 0 point. This guy went off to the left and came back to the right. It's a little hard to understand. I had to read it twice to follow what they were saying. This particle was a particle X, and there's another particle Y, and they start at a point P. Do I know it's off to the right? I guess I don't. So apologies if that's wrong. Yeah, I don't think I do know it's off to the right. Maybe it's off to the left here. But anyway, we have a particle point P, and they tell us a few things about it. They tell us he starts off at speed 7.5, going this way, and they tell us his acceleration gives a formula. Let me write it down over here. A is equal 0.8 minus 0.6. Again, I can actually think about this and say at time 0, that's a positive acceleration. So he's moving this way and speeding up. As this number gets bigger here, this gets smaller, and this turns negative after maybe a little over a second. This will turn negative. So this guy will be going quite fast, and then he'll start slowing down. Still go this way, but he'll start slowing down. Eventually, he should stop and speed up and really really fly off to the left because this acceleration just keeps getting more and more negative. So this guy goes off here, back that way. This guy goes here, off this way. But like I said, maybe this was on the left. And they don't even ask anything like that anyway. But just it helps me think about the question. Okay, what they're actually asking is, they tell us the velocity of this guy. When the velocity of this guy is minus 9.6, show that the displacement of x from 0. So I don't know where he is. Maybe he's over here, or maybe he's over here. Its displacement from x is equal to y. Y is displacement from p. So there's some point where their displacement is equal. You could also see this question being asked, when do they hit each other? Or when are they traveling the same speed in different directions, or something like that. There's lots of things they could ask in this question. The first thing I did was similar to the first thing in part A. They gave me A. Well, I'm going to write V and S. I just always write these guys out. To get these, I differentiate to go down. I integrate to go up. And that's what they want you to do here. They want you to integrate here. That's 0. I haven't left myself enough room. So let me clear them off. Let's say V is over here. 0.8 times t is the integral of that. The integral of this becomes t squared. This goes up 1, and we divide this number by 2. So we get 0.3, and there's a minus here. And then there's some constant. You don't have to put c and solve it, because the constant is the initial speed. And we know what the initial speed is. They told us it was 7.5. 7.5. If you want, you could have put a c here, but then you would have had to solve it at time 0. When t is 0, phi is 7.5. And hopefully you can see that's where that comes from. When that's 0, phi is equal 7.5. The next we have s. S is this t becomes t squared, and this number gets divided by 2, 0.4. Because we're dividing by this number. This guy becomes t cubed, and this number gets divided by 3. So 0.1, there's still a minus. This number just gets a t added onto it, and then plus some initial displacement. This can be any number you want, really. Usually we just pick 0 because we get to decide where it's displacing from. But if they ask for the displacement from 0, I'd need to know this number here. In this question, if we read on later, they do talk about the displacement of y from p. And it starts at p. So we're talking about the displacement from p. We know where it starts. It starts there. It starts at 0. There's a 0 up here. That could have tripped up a lot of students. At this point, it should be quite easy. We've done all the work. If you're able to do both these things, and you did it straight away, you're getting most of these 7 marks. Because what they ask next isn't that hard. They talk about the velocity of y. The velocity of y being, where will I write this here? Minus 9.6. But the velocity of y is also equal 0.8 t minus 0.3 t squared plus 7.5. That's a quadratic. We have a squared, a t squared, a t, and a number. Move everyone on the left to get these guys positive. 0.3 t squared minus 0.8 t. And what did they come? I'll just look it up. Minus 17.1. Minus 17.1 equals 0. It's a quadratic. Use the minus b formula to solve this. That's definitely the easiest way to do this. Although I will point out, you can do this in your head. As surprising as it seems, multiply everything by 10. We get 3t squared minus 8t minus 171 equals 0. I'm not very good at this. I did it anyway, just sort of for the fun of it. I like doing this. I just guessed some numbers that went into this. It turns out 9 goes into this number. So you can factorize this in your head. For example, 3t has to be 3t and t. So 9 went into that. How many times did it go in? 19 times. And I thought to myself, well, if a 9 was here, 9 times 3 is 27. 27 and 19 are 8 away from each other. So 9 and 19 did work. But again, use the minus b formula at any point here, and you'll get the same 2 answers we're about to get. This would have to be a minus, this would have to be a plus, and this would have to be a minus. Minus 27 plus 19 is minus 8. So time would be t is equal minus 19 over 3. That's a problem. We start at 0 and we move up. This is the real world we're in. We're not in maths at the moment. We're in mechanics. Can't have a minus. Or t is equal 9. That's the time this situation happens. They told you the velocity. They're asking us questions about the displacement. We figured out the time, so now we can go to the displacement of both of them. So over here, the displacement after 9 seconds is equal 3 times 9 to the power of 3 over 2 minus 6 times 9, which is equal 27. We can go to this displacement. This s at 9 seconds is equal 0.49 squared minus 0.19 cubed plus 7.5 times 9. Put all that into the calculator. We also get 27. The displacement from 0 here of this guy is for x is 27 away from 0 off to the right. Y is 27 away from p off to the right. That's a shortish question, but it's really hard. If you're not following what I'm saying, well, I apologize because I'm probably just a bad teacher in that sense. Watch the video again. Watch it a few times. These 7 marks they're giving you, it's for thinking this question through. It's not for any hard maths. There's no difficult maths here. A bit of integration, but simple integration, simple differentiation. Difficult quadratic, but still relatively simple. Filling numbers in. You're being given these 7 marks for being able to figure all this out in an exam. I apologize. There's not much more I can help you with that. I'll just show you what I'm thinking. Stay working on it. It does get easier. You will put these clues together the more of these practice questions you do. And if you have any follow-on questions for me, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.